Hello and welcome to our webinar on CANopen profiles and IoT, the Internet of Things. My name is Thilo Schumann and I'm from Canon Automation. This webinar will take about an hour in maximum. Yeah, my name is Thilo Schumann. I'm an electrical engineer for more than 20 years and working as a CAN expert for more than 20 years at Canon Automation. As part of this, I'm also a notified expert in many different national and international standardization groups related to Canon Automation, related to CAN and the like. Over the last years, I'm also specialized in safety, functional safety, as we call it, and security or cybersecurity, as we call it these days. Yeah, that for short about me. If you don't know, Canon Automation is the international users and manufacturers group regarding CAN technology. It was founded in 1992, and we want to foster the image of the CAN technology in general. In any industry, as you may know, CAN was developed originally for the automotive industry in the automotive context, and we try to foster the image in any industry, in any non-automotive industry. Over the last years, it became also very obvious for us that we are going back together with the automotive industry and working with them on the advancement and further development in CAN itself, and also worked hard to adopt that for non-automotive areas. Right now, we have more than 200 members worldwide. As you see, the majority of the members is still based in Central Europe, as we call it. It's more the western part of Europe. Yeah, that's still the main members where they are from. We have also a strong membership in North America as well as in South Europe. As I said, Canon Automation was founded as a non-profit organization in 1992. So this year marks our 30th anniversary. We just had to happen to have an anniversary party for our members with several presentations on the latest technologies related to CAN. We have, over the years, pushed forward the image of the CAN technology by our CAN newsletter, where we talk about latest trends and the latest products and services and like from many different areas, many different companies. You can read the CAN newsletter, of course, these days online. You can download the magazine as a PDF or just read the latest product news on our CAN newsletter online. We organize joint booth at different events. We started at the Intercama, and this year, for example, the Bauma will follow. So we are still working internationally, and we have try to bring together our members in the different areas. Over the years, of course, one of our main topics is also to publish the different specifications. We started with the physical layer specification, the CIA 102, which is still very present these days. Later on, the 200 series, the 300 series, 400, and Yeah, just look up on our website and you will see all the specifications which we have available. We also organize the International CAN Conference, not annually, but regularly come together of different experts from the CAN community to talk about the latest and newest developments in CAN technology. And yeah, just not to finish off, but the current state, of course, is we first we have basically yeah, developed CAN-FD together with various members, and now we have developed CAN-XL together, and we are still in the development of CAN-XL. The first specifications are available, and the first silicon is to be expected within the next few years. Our main focus at Canon Automation are still our specifications, our CIA specifications, as we call them. And sometimes, as I said, we bring them also to national and, of course, international level, into IAC, into ISO, to on the request of our members, and try to bring forward the specification on this regards. And all of our services within Canon Automation are basically formed around those specifications. As I said, we have our International CAN Conference. We present them on other industry conferences. We have our newsletter. We have our seminars. So we are doing marketing, technical stuff. We try to support system designers, device manufacturers, and the like. To prepare our specifications, we are organized in several technical groups. Those technical groups are observed by the technical committee, which is comprised of 5 different member companies. Right now, we have different technical groups, our so-called interest groups. One is related to CANopen, which is more the classical CANopen. Of course, there doesn't happen so much anymore, because then we have our interest group CANopen-FD, who developed CANopen-FD to accommodate the usage and the possibilities of CAN-FD. Then we have our interest group profiles, which observes and is responsible for all of our device and application profiles. We have a very active interest group lower layers these days, which is currently working on the development of CAN-XL and all the related layers around and definitions around, like the physical layer, of course, the data link layer, and also on the data link layer in CAN-XL, there will be some security incorporated, as well as other things like fragmentation and so on. And of course, we have our interest group safety and security. But today's topic of this webinar is about IoT. So what is IoT about? What is it? We have in general terms IoT, but as we are in an industrial context, more like, I would say we are more in the context of industrial IoT. Sometimes this is also referred to Industry 4.0. It is not completely the same, but very alike. And each of the other is connecting. But what or how is Wikipedia definition on IoT, on industrial IoT? And we see, according to the definition, industrial Internet of Things refers to interconnected sensors, instruments, and other devices devices network together with computers, industrial applications, including manufacturing and energy management. This connection allows for data collection and exchange and analyzes, potentially facilitating improvements in productivity and efficiency. So we see that's basically what CAN is about, what CANopen is about, what we are doing for years. We are interconnecting sensors and actuators, and we are doing control on these. We are doing, and this is used in manufacturing and embedded machines, in energy management. So in all these different areas. So CAN-based systems, and of course CANopen-based systems, are fit pretty well in this environment. But how do they fit in it? So here, just an example on the general idea of the IoT architecture, how that fits together. And what we see here is there is somewhere the cloud, whatever the cloud is. I call them sometimes just other people's computers, but let's take the cloud. And the cloud is connected to the internet, and to the internet we have our local networks via some gateways, edge gateways sometimes called. Maybe they are connected wirelessly in some way or another. So if we focus more closely on the edge, basically on our local networks, which are basically our CAN-based networks, then we have their connectors connected, all the sensors, actuators, control units, and all these kind of things. We have connected HMIs. Maybe the networks are connected to each other. And then we have an edge gateway, a gateway which is connected to some other network, to maybe to the internet. So how does that work in a CAN-based, in a CANopen-based context? And here I have to say we have two main topics in how to connect those and how we can support it. We have one topic, which are, I would say, generic gateway solutions. So we have generically the possibility to connect any CANopen-based network to the internet by various means. Of course, we can't support all IT protocols very easily because it takes time to develop this and to come agreements within our member groups, but we still have a lot there. And of course, we are working also on specific functions. And here is, for example, just for lift applications. So how those generic gateway definitions, gateway solutions work. Our main part here is our CIA 309 series. So our 309 series basically describes a general CANopen access from other networks. Or you can also, it is named that way, but you can also, of course, access CANopen other networks from CANopen side. We have several parts in 309, and so we support different kinds of interfaces here to, or gateway types or other protocols to connect to the internet. Of course, we have Modbus TCP/IP, namely to connect to the internet. But actually, we could use not only Modbus TCP/IP here, we can connect to Modbus in general. So on the RS-485 defined version. We have a generic ASCII protocol that can be used over basically anything that is able to transport ASCII. That could be Telnet, that could be SSH. that could be a serial connection. So we have a very generic ASCII protocol. We have definitions on how to connect to Profinet IO. We have a RESTful API and WebSocket. Currently, we have a first proposal on MQTT, so it is in development. We have an OPC UA in development. And then I will also add a few words on a generic wireless transmission media, which is defined in 3.15. So first, start with our generic gateway solutions. What do we have there? Or what is the part here? What is the content here? So in a 309 context in our generic gateway protocols, the idea is I have an whatever type of network, I would call that here right now upper network, and I want to receive some data, whatever that means, from our CANopen network. And not only from the network, I want to address maybe specific devices within this CANopen network. And then, of course, the answer travels back. So we have, as I said, there are different definitions. We have the Modbus TCP/IP mapping, as I said. We have the ASCII mapping. We have the Profinet definition, and we have RESTful and WebSocket mapping. What is Modbus TCP? The Modbus TCP/IP mapping is very simple. Let's assume that the blue part basically is the Modbus TCP/IP data unit, or Modbus RTU, as it's called. Then we have, together with the Modbus organization, we have agreed that we are using a specific function code, which is defined as 2B in hexadecimal. And together with the function code, we have the Modbus encapsulated interface type, and this is defined as 0D in hexadecimal. So we have the assigned function code and the MEI type. And if that is used in Modbus TCP, then we know that a specific CANopen request is being made to a CANopen network. So that means this Modbus TCP message can travel through the whole Modbus network, and at the right gateway, it is then terminated into the CANopen network, and the response is being generated. Of course, then all the additional CANopen specific data needs to be added to address a certain device within the CANopen network. Maybe I want to address a certain CANopen network. Maybe I have several CANopen networks connected to with maybe different Modbus gateways to Modbus network. So I can address all these different CANopen networks. And for that, I have a node idea, of course, because I want to address a certain device. I want to address a certain data value within the device with index subindex. And then I can transmit the data, either reading. Of course, when reading, then all the data is not being transmitted at first, and it's just a command message, a request message. And then the data is being part of the response. Or if I want to write, I can send the data or write accordingly. So we have a simple and straightforward way on how to connect CANopen-based networks with Modbus. Here, just a example, we can even not only transmit or request data from the object dictionary of a device connected to CANopen. We can also manipulate the network management state machine. We can get other data like emergency. We get all timestamp. So all the services which are defined in CANopen can be addressed from within Modbus TCP/IP. And here in this example, I just have written down the example for the NMT message on how to control the CANopen device, or basically the state machine of the NMT state machine of a CANopen device. And with that, I can start or stop the network and log. So you see, with Modbus, we have the first possibility to connect any CANopen network to Modbus and thus to the internet. The second, or another way, was, as I call, the ASCII protocol. It's a very simple, straightforward protocol. Here as an example, you see the definition for the request, for the command request, and as well for the command response. Of course, we again are able to address different commands like reading data, writing data from the object dictionary of a certain device. We are able to transmit process data object. We are also able to transmit again the different services like network management, emergency, timestamp, and so on. To give a short example here in the ASCII protocol on how it's like, we have here, for example, an SDO read request, where we see that that we have our read request on a certain index, sub-index, and with the data type, and then I get the value. I can address a certain node, a specific node within the CANopen network. So if I have the gateway just connected to one CANopen node, I don't need the node address, because then the gateway can directly communicate with the CANopen device. But if I have the gateway in a CANopen in a real network connected, of course, I may have to address all the nodes within the network. So I need to know the node address, the node ID. Again, here to the gateway, there could be different CANopen networks connected. So I can address the different networks with their network number. And I can even do not only sequence commands in sequence, I can fire commands even in parallel and addressing those different commands by giving them a certain sequence number, whatever I like, and then I can identify the response on the sequence number. So I can make very powerful gateways in here, not only simple one with small amount of memory and small amount of resources at all, which are just able to process commands in sequence. I can even use some high profile devices, gateways, which can do things in parallel, and then I can address those parallel requests and get the responses. So we see with the ASCII, and as I said, the ASCII protocol is just an ASCII protocol. We haven't really specified the underlying layer where the ASCII is being used. So in a simple way, of course, I can use that on any telnet session. I can use that in an SSH session. So I can use any interface, any network layer, which allows me to transmit ASCII data for some bank. Very simple protocol, which of course is very powerful if we think about configuration, if we think about remote diagnosis, if we think all these different things. It is maybe not so it is okay for visualization, but maybe not so good for real control purposes. Another way is, I have here already shown the slide, is the RESTful API. As you know, how the REST API works. The RESTful API works is I have some client connected via the cloud, via the internet, and I can do HTTP requests. And then HTTP request could be a get, post, put, create, put, delete, and so on. And I have my API, which processes this and forwards that to the according server. The server could be also a database. So that means the API, the gateway in between, some gateway basically is transforming the standardized request into a specific request the server understands. And in our case, it is not any kind of server, it's a CANopen network. And the response is then formatted in either JSON, XML, or in plain HTML. So that is the generic definition of a RESTful API. In case of our definitions, the response is in JSON. So again, we have basically 4 different methods. The get method is to receive data. The post method is to create a resource or to post data. Put is more to update a specific data, and delete is to delete a resource. In CANopen networks, I can't really buy software. I can't really delete devices or data within a network. I can only request data and I can write data. So we are using basically the get and post methods to receive data from the CANopen network or to post the data into the CANopen network. And how do we do that? We have the definitions. We have a clear URL syntax, as you like to call it, where we can address all the data. So we have our definition that we are using CIA 309-5. So maybe that changes in the future. Maybe we have a different specification in future which allows to address other things. Or maybe on the same server, this API endpoint is used also to address other RESTful APIs with other backends which are not CANopen. So we can pretty nicely work together with other RESTful APIs in this regards. We have then an API version. Again, we can have a sequence number. Again, we have our net address and node address. So again, we can address several CANopen networks. We can address all the CANopen devices within a network. We can read or write, and we can address the data index, subindex, and so on. So in a real world, that would look like this, for example, if I want to retrieve data from a certain node, from node number 5 connected. So I can make my get request with network number 2, node number 5. My read request to object 1000, subindex 0, unsigned 32 value. And then I get my response as a standard HTTP response as it is in RESTful APIs. And here I get my JSON object basically. So I can do a direct addressing via the net number and the node ID. So I can generically address and get any data from it. It's not only here that it's just an example. It's not only that we can read and write the data. Again, we are able to control the network management state machine in the devices. We can have access to emergency, to PDO, and the like. So again, we have the very same access types and access possibilities as we have in the ASCII protocol and in the Modbus TCP. With the RESTful API, that said, with the RESTful API, we have another possibility to address data. Because maybe I don't, as someone connected to the internet using the RESTful API, I don't have any knowledge about the physical setup of the CANopen network. So I don't know anything about CANopen network numbers. I don't know anything about CANopen node IDs and alike. So I just want to address, I want to read or write certain data. And for that, to make that possible, we have also an indirect way of addressing data. We call that reference designator. So that means in the system setup, in the network setup, the system integrator can set up a database and assign to certain data in the network, which is distributed over all nodes within the network, a dedicated reference designator, so a dedicated name to my data, which then is being basically transparently forwarded onto the RESTful API and make visible at the RESTful API. So with that, I have some kind of basic security access. I wouldn't call that really security, but it's some kind of access level control. Because with the reference designator, I can make only the data available which I want to make available, and I can name them appropriately. And again, here in this example, I have the same request. I have called that now parameter reference. In this example, it's called parameter reference, and then I get the data back again. So here again, I have different ways of accessing the data. MQTT, yeah, as I said, yeah, RESTful API is like the ASCII protocol. It's a polling method. So I can push data, I can do a request. I need, from the client side, I need to make an active request into the API endpoint, which is some server. I need to make that active. So I can only, yeah, on every push and pull on any request, I can receive or transmit data. I don't get any immediate update when data changes, like we normally used to have in CANopen networks. So I either need to constantly pulling the data in a loop or so. And MQTT is designed as a publish subscriber mechanism. So it's a completely different in this way, where I can say I want to subscribe to certain kind of data from within the network, and then I get automatically being updated if I on the data I subscribe to. For that, we need a so-called MQTT broker. We have a first proposal from some member companies that is already being distributed within our members. But it happened that we have no working draft right now. So if you are really interested, I would call that more work in progress in here. So if you are interested in these kind of things, be invited, be a member, and work on this. So here right now, I already showed the different generic gateway possibilities with Modbus TCP, a very well-established kind of network. We have the generic ASCII protocol. We have the to connect to Profinet IO, also, I would say, well-established kind of network. We have the possibilities to provide a RESTful API. What I didn't really show was WebSocket. It is somewhere hidden in the RESTful API, but it allows some kind of streaming service. So to be updated when data changes. And we are working on MQTT. Unfortunately, as I already said, I haven't said too much about OPC UA because that's still also work in progress. I'm personally currently working on that together with the OPC Foundation. But I want to bring your focus to another specification we have, and that is how to connect wirelessly CANopen networks. And that is defined in CIA 315 with our wireless transmission media. So it is defined as to have a generic wireless transmission of CAN messages point to point. So point to point means on the wireless network. And that could be one CAN-based network on one side of the wireless gateway and another CAN network on the other side. So the original idea is basically I have like an off-road vehicle, a construction machine, and in the construction machine, I have some remote sensors connected via Bluetooth BLE, via the Nordic NRF protocols, or whatever generic RF protocol I would like to use. And how can I get the data from that? Not only to get data, maybe also to inquire additional information about the quality of my RF network, about configuration parameters of my RF network, as well as configuration parameters of my CAN network and the different higher layer protocols. But the 315, even if it is within the CANopen range, is a generic definition. Very generically allows transmitting of CAN messages with different protocols on top, of course. So we see, as just an example, I have my whatever wireless protocol, I have a preamble, maybe a packet length, sequence number or not, and a message type identification. And then within the payload is our CAN telegram or CAN message. And it is possible, of course, to combine several CAN telegrams if the wireless transmission allows that into one transmission. And then, of course, here in the example, I just have one CAN message. Then here I have my message identifier, my data length code data. I even have my timestamp. So the gateway, the wireless gateway that receives a CAN message and transmits it to the other endpoint of the wireless can transmit a timestamp when the CAN message was received. So on the receiving side, I can bring all the CAN messages in order, and I know when it should be or when it was originally transmitted at the originating CAN network. And as you can see, I can combine a number of CAN messages together. And as we transparently or generically transmit CAN messages, we can transparently support any CAN-based protocol. It could be a proprietary CAN-based protocol. Of course, CANopen is supported, J9039, whatever you like, whatever you use. So we see we have many different generic possibilities to connect CANopen-based networks to the wide world. Just to give you a short example on specific gateway functions, I have here included lift application. We have also some, let's say, we have other profiles who partly worked on that, not really in the device profile area, but in the application profile area. We have some profiles who worked on that. In this regards, for the lift application, it is this way. As we imagine our complete lift application, which can have up to 8 lifts in parallel and up to 254 floors, then that would be the general architecture. It allows me, we have a part of the lift application definition, we have the possibility to remotely access certain data. And this is basically specific data. Of course, with the generic possibilities to access a CANopen network, we can access any kind of data. But within the lift application, we have dedicated types of data, which allows us predictive maintenance, condition monitoring, which allows us process visualization, and even remote diagnostics. So that means within the lift application, before the whole lift, the idea is to allow remote access to the most important information. So to make it to the implementer of a gateway functionality, like the RESTful API, to identify all the data. And he doesn't have to look through all the specification, what makes sense to communicate to the cloud for remote access, but to make it much more easier in a more concise way. All that said, we sometimes not only have some cloud, some TCP IP-based network, which is connected to our CANopen network, but we may have also hierarchical CANopen networks. So, and then the question is how I'm able, like above is the cloud, and there's connected some client. Maybe I have my application manager, which implements RESTful API or the ASCII protocol in some way or so. And the question is, how do I acquire data from below? And I said, in many of our definitions, we have a net number. So that means we cannot only have several CANopen networks in parallel connected to the gateway, but we can have a hierarchical organization with CANopen to CANopen routers in between. So that means the application manager can talk to the CANopen router and can talk to CANopen router and can then talk to the node. And so the data can be forwarded all the way down where I need to connect it. And for that, each and every CANopen router can have up to 32 dedicated ports or network interfaces, as we call them. Each CANopen interface has its own network management state machine, SDO management, PDO management, emergency error control. And then we have a shared object dictionary. And all the data can be addressed or inquired via remote SDO services, remote NMT requests, remote error control, and so on. So I can receive on network 1 maybe a remote SDO for networks 32, and that is being forwarded then to network 32, and then by the gateway and the data is then basically translated into an SDO request on network 32, so that the data request is forwarded to the right node and all the data can travel back. So that means even with classical CANopen, we can build hierarchical networks and all that connected to the cloud, and I have all the possibilities. That said, that works for CANopen, for classical CANopen. Because in classical CANopen, originally, we didn't know about anything like a network number. It was just now with the hierarchical structure introduced. In CANopen-FD, we introduced it directly into the protocol. So we have directly in the CANopen-FD protocol an inherent routing capability. So it is already part of our universal SDO, our USDO in CANopen-FD. And just here as an example, we see our remote USDO. We have our USDO upload request, which is just local. That is like in a classical CANopen, the related SDO request, which just contains destination address and command specifier. But we directly support in CANopen-FD the remote USDO. And you see here in the remote USDO, we have now added a destination network ID, a destination node ID, and a source network ID and a source node ID. So, of course, it is being forwarded to a local destination, maybe to another gateway. So we basically do source routing. I need to know what is the next gateway or the gateway who's transmitting such a remote USDO needs to know what is, can I just terminate the SDO request in my local network, or do I need to forward it to the next gateway, so basically to the next hop. And the originating requester can, of course, put in its source node network ID and and node ID. Of course, that is required to transmit the response back. And of course, we need our destination. So we have a complete routing capability inherently available in CANopen-FD. With that said, cloud and big data with CANopen networks? Yes, of course. It's not our business, but we can do that. We provide everything. We give the possibilities to access any kind of data within a CANopen-based network. So it's possible. But there's at the end just one thing which I would like to remind you. I don't want to go too much detail here, but I want to remind you security, cybersecurity. You need to do your homework because the security needs to terminate at the gateways. You need access controls. You need, so even if I said you can transmit the ASCII protocol on a telnet session, you don't do that anymore. Use SSH and use the latest protocol versions and algorithms in SSH. So you need to do your homework on the internet side, of course. And you need, if you do security, of course, you need to also do a security incident management, because if something happens to the systems, you are responsible in any way. And with that, I'm almost at the end. Yeah, is there an XKCD for anything? Yeah, it is. Just to remind you again, security and IoT. Think about the cloud as other people's computers. Your IoT network may become other people's toys. So be reminded, do your homework. And with all of that, I would like to thank you in participating our webinar on CANopen and IoT. So if you have any questions, you can ask them in the chat, or you are able to contact us maybe at service@CAN-CIA, and we will try to help you with your needs. Thank you for participating. I will close the session now.